Hi everyone! In this video we're going to learn how to graph the sine and cosine functions. We're going to start by observing some interesting facts about the graphs that will later help us to sketch them. We're looking at some arbitrary graph. Well, it must be a graph of the sine function since the graph crosses the vertical axis at the origin, but that's not the point of this picture. What I want to look at is one period of this graph. I can see that in this case, one period covers 5 special points of the graph. 0, maximum point, another 0, minimum, and another 0. And if I project these 5 points to the horizontal axis, in other words, I find their corresponding x values, this is what I'm going to find out. Because of the symmetries in the graph, these points split one period into 4 equal parts. 1, 2, 3, and 4. I'm wondering if it just happened in this particular case for this particular graph. Well, let's look at the graph of some arbitrary cosine function. Notice how it crosses the vertical axis not at the origin, but up here. Here is one period of that graph. It stretches from the maximum point to the next maximum point. And these are all key points of that graph within one period. So maximum point, 0, minimum point, 0, and maximum. So what happens if I project them all to the horizontal axis? This is what I'll get. So again, I can see that one period is split into 4 equal parts. And the truth is that we can generalize this property. Important points of a graph within one period, and I'm talking about minimum, maximum, and 0 points, always subdivide one cycle into 4 equal parts. And that's something that we're going to use for graphing purposes. When graphing the sine and cosine functions, it's common to label the horizontal axis only with the x values that correspond to maximum, minimum, and zeros. And the key idea is that these points split every cycle into 4 equal parts. So this will help us to find values that we'll need to label the horizontal axis with. Let's practice this. First, let's just practice labeling the horizontal axis. Because once we learn how to do that, the other steps of graphing the sine and cosine functions are very easy. So we're given period 2 pi, and we need to label the horizontal axis within 2 cycles. Now this is how I'm going to think about this question. I'm going to start by labeling 2 pi. Well, it's period. It means that it's going to be at the end of the first cycle, let's say over here. So we just learned that the important points of the graph, maximum, 0, and minimum, split every period into 4 equal parts. That's what I'm going to show on the horizontal axis. So segment from 0 to 2 pi, I'm going to split into 4 parts. First, I'm going to split it right in the middle. That gives me 2 equal parts. And then each half I'm going to split again right in the middle. And that's how I'm going to obtain 4 somewhat equal parts. And my goal will be to label each place that I just marked. I will always start with the very first one. Since its length is 1/4 of the period, or 2 pi, I can algebraically find it by taking 2 pi and multiplying it by 1/4. So 2 pi times 1/4. And this fraction 1/4 will always be there for this step, because the first label will always mark 1/4 of the period. So that is 2 pi over 1 times 1/4. I divide out 2 and get pi over 2. So that's the value I'm going to place at the horizontal axis for the first mark. Now, how about the rest of them? I know that the distance from 0 to pi over 2 is pi over 2. So that means that the length of that little subsegment is pi over 2. Well, and we just said how those little subsegments are equal in length. Well, that means that they're all of the length pi over 2. So to find the rest of the labels, what I'll do, I'll keep adding pi over 2. So plus pi over 2, plus pi over 2, plus pi over 2. And to make my computations easier, first I'm going to add without simplifying any fractions. And then I'm going to clean everything up and produce final numbers that I put on the horizontal axis. So for now, I'm going to be writing my notes above the axis. So let's see, I have pi over 2 plus pi over 2. That gives me 2 pi over 2. 2 pi over 2. Then another pi over 2 gives me 3 pi over 2. If I add another pi over 2, I'll get 4 pi over 2. And this is going to be my checkpoint to see if I calculated this all correctly. See how 4 pi over 2 simplifies to 2 pi. So that means that my computations are correct. And at this point, I'm going to keep going because the question was to label horizontal axis within 2 cycles. So I need to keep going. But first, I'm going to label where the second cycle ends. Let's say over here. Well, 2 periods will be 4 pi. And once again, the second cycle or second period, I'm going to split into 4 equal parts, right in the middle, and then each half in half. And I keep adding, so plus pi over 2 and so on and so forth. We stopped at 4 pi over 2, so now I continue. It's going to be 5 pi over 2, then it's 6 pi over 2, 7 pi over 2, and 8 pi over 2. Again, I can see how 8 pi over 2 simplifies to 4 pi, so it confirms that I calculated everything correctly. And once I count that way, now I'm going to simplify everything that can be simplified, and I'm going to put the final results below the x-axis. So pretty much what I have written above is just my scratch work. So 2 pi over 2 simplifies to just pi. 3 pi over 2 I cannot simplify, so I keep it. 2 pi, we have 5 pi over 2, I cannot simplify. 6 pi over 2, that's same as 3 pi. 7 pi over 2, and 4 pi. And once I place the simplified values below the horizontal axis, I'm ready to erase all the scratch work. I don't need it anymore. So that's how the final answer will look like in this case. If we were given a function, we would be ready to start graphing it. But let's try another example of this kind. This time, period is 8 pi over 3. Okay, we start by putting that value on the horizontal axis. That's where the first cycle ends. And now we split the segment from 0 to that value 8 pi over 3 into 4 equal parts. First, right in the middle, and then each half I split on half. Now I have to figure out this first value. Well, since this segment represents 1/4 of the period, I'm going to find it if I multiply 8 pi over 3 by 1 over 4. So I divide out 4 and I get 2 pi over 3. So that's the value I'm going to place here for the first label. And now I can see how this little subsegment from 0 to 2 pi over 3 has its distance 2 pi over 3. And that means that the rest of those equal subintervals, they also have length 2 pi over 3. So for me to find how to label the rest of them, I just need to keep adding 2 pi over 3. And as I add, I'm not going to simplify any fractions to make sure that I keep same denominator. So let's try 2 pi over 3 plus another 2 pi over 3. That gives me 4 pi over 3. Then as I add another 2 pi over 3, I'm going to get 6 pi over 3, and the next one will be 8 pi over 3. At this point, I check that I got the right number. Yes, that's exactly what I need to get. But I am asked to label 2 cycles. So that means that I need to continue counting. So for this example, I'm just going to say, well, the second cycle ends here. I'm going to split second cycle into 4 equal parts. And I'll just continue counting. I keep adding 2 pi over 3. So next one will be 10 pi over 3. Then it's 12 pi over 3. 14 pi over 3. And then 16 pi over 3. I can see how it checks as well. 8 pi over 3 plus another 8 pi over 3, in other words 2 periods, will give me 16 pi over 3. Okay, once I got all this scratch work, now I just have to clean things up and produce final version of each label that I will place below the x-axis. Let's see what can be simplified and what not. So 4 pi over 3 I cannot simplify, I'll just rewrite it. 6 pi over 3 simplifies to 2 pi. 8 pi over 3 I already have. 10 pi over 3 I cannot simplify. 12 pi over 3 becomes 4 pi. 14 pi over 3 I cannot simplify, and then finally 16 pi over 3, like that. So once I have all those simplified fractions, I can erase the scratch work. So that's what we got. Now I'd like to point out that when we were asked to label the horizontal axis within 2 cycles, it didn't actually say that we have to continue to the right along the horizontal axis. Technically, we could label 2 cycles on each side of the vertical axis. So I could label cycle number 1 on the right-hand side of the vertical axis, and I could also label another cycle to the left of the vertical axis. That's the one that will contain negative values, and that's actually very easy to do. Let me show you. If I extend the horizontal axis to the left of 0, as I already said, we're going to have negative values, and they're pretty much mirror reflections of the positive values on the right-hand side. So I already have all the numbers I need. I'll just have to attach negative signs to them. So that's where I'll place negative 8 pi over 3. That's the end of that cycle that lies to the left of the vertical axis. And then I split it into 4 equal parts. And the numbers that I'm going to place are negative 2 pi over 3, negative 4 pi over 3, and negative 2 pi. So that's how I could easily label the horizontal axis within another cycle of the graph. Now let's try the actual graphing example.